Hi, welcome to video 8.5a part 2, integrating using partial fractions.
I'm going to ask you to integrate, okay? Now remember, there's someone we always need to be looking for whenever we have a fraction, and that is our friend Dolly. We have to make sure that in case the degree of the numerator is greater than or equal to the denominator, we must begin by dividing, okay? Now that's not the case in this example, but you must do that first or you will not get the right answer, period. Okay, so this one's not a dolly, so the first thing I do is factor the denominators. 2x plus 3 times 2x minus 3. Then I rewrite it as a fraction, one with sum of two fractions, one with the denominator 2x plus 3, the other one with the denominator 2x minus 3. I'll call those numerators a and b. Multiply both sides by the LCD, you get this equation. You're purposely going to replace x by 3 halves. That'll allow you to find the value of b. Then you'll replace x by negative 3 halves, and that'll allow you to find the value of a. The rest is pretty well arithmetic. There's your a, there's your b, and then you're going to rewrite this original fraction, the integral of that fraction, as the integral of a over the 2x plus 3 plus the b, which was the 1/6 over 2x minus 3. So you can pull out the 1/6, negative 1/6 here, you can pull out the 1/6. Now what you're going to do is let u equal the denominator. If u is 2x plus 3, du is 2 dx. Introduce the 2, counteract with a half. Same thing here. Let u equal 2x minus 3. Derivative is 2 dx. Introduce the half, counteract with a half. Introduce a 2, sorry. Counteract with a half. You get negative 1/12, and you're integrating 1 over u du, which is ln absolute value of u. Same thing here. So pretty straightforward once you get the fraction decomposition. So here's another one, already factored for you. Okay, so I'm going to go through this pretty quickly. The three fractions you'll need: one with x squared, one with x plus 1. Multiply both sides by the LCD. Obviously, we're going to let x equal negative 1, and we're going to let x equal 0. So if we let x equals negative 1, we get c equals negative 2. We let x equal 0, we get a equals negative 1. We still need to find b, so we let x equal some other number. 1 sounds very convenient for me. Again, plug it into both sides of this equation. But remember, we have a and we have c, so we plug those in, and that'll allow us to find b. Once you've got your a, your b, your c, here's your a, your b, your c. We're now integrating that. This is the integral of x to the negative 2, but you have a negative, so it's x to the negative 1 over negative 1, but you have a negative, so it'll become positive. This is 2 ln absolute value of x. Here, let u equal x plus 1, your derivative is dx, so it's negative 2 ln. Goes from 1 to 5, plug in the 5, plug in the 5, plug in the 5, minus, plug in the 1, plug in the 1, plug in the 1, and then subtract, and then they get fancy with all the stuff you can do with it.